Welcome to our second day of Tech Week, an event made by Avenue Coders focused on innovation. Yesterday was an amazing day with an amazing schedule, and today will not be different. Yay! So, thank you so much for being here with us today. In this session, we will also welcome clients from different companies who are our special guests. So, thank you for being here with us too. And I would like to remind that our space for exchanges, questions is in the AC Hub, our internal social network, in the group that we created for Tech Week. So please, if you are an Avenue coder, go there. And today we will learn a little bit more about three-dimensional modeling techniques. Oh my God, so fancy, so fancy. With our incredible Dayany Santos. Day, thank you very much for your time. It's up to you, and you can share your screen now.
Okay, thank you, Joe.
You're welcome.
Let's sharing a minute. You can see my screen?
Yes.
So today we are going to talk about some three-dimensional modeling techniques. I'm going to do a quick briefing about myself and talk a little about the project that I worked at my college, which brought me to these three-dimensional techniques that I will be talking about today. We'll see a little bit of what is computer graphic, and finally, we'll be speaking about the techniques and the conclusion of the research project. Well, hi, my name is Dayany Santos, and usually I introduce myself as Dayany Anaile because here in Brazil, we don't have much of the custom to introduce ourselves with our last name, and Anaile is my second name. I don't know if it's right to say composite name, but okay. This is the reason you guys will only see me on social medias as Dayany Anaile. Okay, so I am a front-end software developer. I'm a very creative person, and this is usually why I lose my sleep because of this. And I am an artist, and if you don't believe it, I can prove it that I am an artist. So this is some of my drawings, but I love to do watercolors paintings when I'm on my free time. It is my therapy. And if anything goes wrong as a developer, I think I can work it out in another way. So right, before I introduce the techniques, I need to talk a little about the research project that I worked on my college that I said, Federal University of Mato Grosso. And the reason I had the opportunity to learn these techniques that I'm going to talk about. So the name of the research was Factor for the Design and Evaluation of Three-Dimensional Virtual Environments. This project is part of the LAVI, Laboratory of Interactive Virtual Environments. If you want to, I can share with you guys a link that you can know more about LAVI later. And the project is run by my teacher and PhD, Eunice Nunes. And we had the opportunity to launch 3 games on the Play Store as the result of this amazing project. Talking about the games, this one is Hospital Meeting, and it is an educational game for children with the aim of simulating everyday medical procedures and to help children get used to the hospital environment and the elements that make up the medical procedure. This one is Protegendo a Terra, Protecting the Earth, and it is a 3D game with the purpose of encouraging sustainable behavior and preservation of the environment in order to reduce the environment impacts caused by the lack of awareness of citizens in their everyday life. In the second phase of this game, we encourage the kids to learn how to make toys with the objects that they recycle in the phase 1. This one, it is the last one that I had the opportunity to work on the development. It is ABC Diabetes, the game which aims to prepare children and young people initially diagnosed with type 1 diabetes about their treatment, such as, for example, the best choice of food and its relationship with the level of glucose in their body. Any of these 3 games can be found on Play Store. Only Play Store, not the Apple Store, sorry. Now let's get some idea about what is computer graphics, sorry. So computer graphics, as known as CG, is a set of algorithms, techniques, and methodologies for the treatment and graphics representation of the information through the creation, storage, and manipulation of computer drawings and graphics peripherals. We already know that CG is applied on different sectors of the economy, such as entertainment, movies, games, education, training, art, geoprocessing. Okay, but what is the problem that we have to solve here? We all can clearly see the evolution of not only the CGI, the CG, sorry, not CGI, but all of the technologies, and we are here on the TechWeek, especially to speak about this. But even with all the technology advances, game developers and virtual environments developers find limitation in the performance of the 3-dimensional graphics processing when graphics is greater realism and low processing costs are required. So Tony Albrecht, one of the engineers on the Render Strike team under the Sustainability Initiative of the League of Legends, said there are over 10 million games per month played on Windows XP. According to him, Windows XP is currently the 4th most popular OS version running the game League of Legends. Okay, so let's get what matters in this presentation. But before, I want to talk about rendering. So most computers have CPU, Central Processing Unit, and GPU, Graphics Processing Unit. The CPU is responsible for the game's logic and calculation, while the GPU receives triangles and texture data from the CPU and displays them on the screens as pixels. Small GPU programs called pixel shaders enable us to affect how this rendering occurs. Why am I talking about CPU and GPU? It's very important to know the impact of the triangles and the textures on the GPU, so you can understand how important it is to know these techniques. Right. So the first technique is Polygon Reduction. Young, on his article, System and Methods for Generation and Optimized 3D Model, presents the optimization of the lowest polygon counts on 3D objects, intending to reduce the cost of VR graphic processing on smartphones and tablets. Okay, but what is a polygon? So talking about 3D objects, the number of faces shown is simply the total number of the polygons in the scene, including all triangles, squares, and n-gons like pentagon. So here we have a cube. And in a cube, we all know that has 6 faces. So on the left image, we have 6 polygons. But in the we can multiply our polygons, but we still have the same shape, like in the right picture. We still have a cube in his own form, but we have like 150 polygons because we multiplied his polygons and not his faces. He still have 6 faces because he's a cube. Okay, so in this figure, we can see that the modeling of the crackers, wait, let me explain. This is a plate, and we have French bread, an egg, some apples, and some crackers. So in these crackers, we use the 6 faces in the shape of a flattened cube. Meanwhile, the modeling of the other objects is composed of more polygons in order to become as close as possible to a real object, such as the French bread, the egg, and the apple. So considering three-dimensional virtual environments that are composed only by 3D objects, each reduction in the cost of processing the objects through the limitation of polygons is remarkable for the virtual environment. Okay, next, and the second technique is UV mapping of textures. Klua and Bitterkurt, in their article, Desenvolvimento de Jogos 3D, Concepção, Design e Programação, emphasizes that the importance of the texturing technique to represent with the greater realism of the materials that it is part of the 3D virtual environment. Here we can see more clearly the plate that I was talking about. And we can see that was applied the UV mapping texture method. And we could apply the texture on the modeling of the French bread and the crackers, providing greater realism for both objects. And now you can see that it is a plate of some breakfast. Previously, we couldn't understand what was on the plate, but you guys could suppose that they were French bread, crackers, an apple, and an egg, because I told you so. And now, with the textures, we can all see it clearly and with greater realism. So now I'm going to show to you guys the 2 techniques that I talking about being applied on the League of Legends, a game very famous. So here we can see the optimization of the polygons. On the left picture, we see the character as in wireframe mode, and we can not see, but it has 6,336 triangles that make the champion. And in the right picture, we can see him in solid mode. And this champion is called Garen. And so she isn't flattened, shaded. This is a limitation of the application being used to inspect the rendering. This is the texture, a crazy texture, but this is the texture of the champion. And now it will be used with the UV mapping of textures. And the champion without the texture is almost unrecognized as the plate of the breakfast that I shown to you. So to bring Garen to life is needed to apply a texture, this crazy texture. So now finally can see the final look of the champion that will be seen on the game. He is more clearly, and we can associate with his character. We can see now that he is a warrior and he's a champion of League of Legends. So to the conclusion, why is it important to know these two techniques? So the technique, when applied, can maintain the realism of the virtual environment developed, but with a lower processing cost, make it possible to run on different model of smartphones, tablets, and computer OS versions. So it is very important because we can still have the realism and the greater computer graphics with lower processing costs. So this is it. If you want to know more, I wrote an article on my LinkedIn. I can send you the link later or in the chat. And this is it. Thank you. Any questions?
Yay, nice. Since we still have some time, does anyone have some question? Want to comment something? Okay, nice.
Hi.
Oh, go there, please.
Hey. I have a question about which engine did you use to build the games on the university projects?
So I use it as a designer. I was a designer. I use it Blender to do the 3D modeling.
Yeah.
And for the game, we use it Unity. So that's it.
Okay. Thanks.
You're welcome.
I do have. Oh, go ahead. Sorry.
No, please, you started first. Go ahead, Noel.
Yeah, I was just thinking about there is like a specific count of polygons for using characters in game. Like for example, for film and stuff, we usually do not care that much about polygons, but instead of games, we need to optimize it so we can run the game fluidly. So is there like a specific count of polygons for games?
Well, I'm not a specialist in this, but it depends on your game. So if you have all the virtual environments in 3D, you will have to lower your costings of your polygons. It usually call it low poly and greater poly when you have low poly, when you have a less of polygons as possible. But it will be only depends on your project and your game. I hope it's responds your question.
Yeah, it answered. Thank you.
Welcome.
So I'd like to first thank you for sharing your knowledge. It's such an interesting matter that you brought to us. Thank you for that. And you've mentioned that you were a designer before. I'd like to understand your point of view. Why did you go to development, and how do you think these two different worlds work together, and what it can bring to our clients?
So I did this project on my college as computer science. So in the end of the college, I had to become a developer. But I worked as a game designer on the project because, as I told on the beginning of the presentation, I am very creative person, and we had a few people to work on this project, so they pushed me to the designer. But now, as a developer, I see that it is very important to the developer know these essential things, and the designer as well, because sometimes the designer just do creative things and doesn't think about the processing costs. And the developer only thinks of the processing cost and the limitation of the environment. So it is good to have this communication and to understand. So I think it's it's very important to know both sides.
Thank you very much, Dayany.
Thank you.
So,
Hi.
Alex, you can go.
Yeah, I think it's me. First of all, congrats, Dayany, for your presentation.
Thank you.
And my question is just a curiosity. There is some technique about the, I believe that's called degree of detail. So objects far away have less polygons, and objects that are closer to the subject may have a greater detail. There is some technique about it?
So I just shown it two techniques, but there are a lot of techniques. And with the reduce of the polygons has another forms to do it. I was trying to remember the technique name, but I just forgot. I will try to search it, and I will try to post it on our AC Hub. But there is a technique that you can freely modeling your 3D model without thinking about the polygons. But in the end, you will come with a mesh over your model, and you will adjusting the polygons on this new mesh. So you will be you will have your original 3D model, but with with less polygons. I didn't know if I could answer your question, but I can search it more about this and answer you later on the chat.
Okay, that answers. Thank you.
Any questions? Okay, then if someone changed their mind, there's no problem. We have AC Hub. So, Dai, thank you so much for the presentation. It was awesome. Thanks for sharing all this knowledge with us. I'm sure we learned a lot today. And I wanted to ask you, everyone here, please give us your feedback about the presentation, about TechWeek. The link is on the chat. So that's it. Thanks, Dai. Thank you, guys, and stay tuned for the next presentations. Don't miss any. See you tomorrow. Bye bye.
Thank you. Bye bye.